Okay, folks, so I guess the number of beeps seems to slow down. I think we have 36 people, which is kind of a good bit. I hope you can see the slides with the Lake Virtual Interim heading.
No.
Sorry, say again?
No, I cannot.
We cannot see the slides.
You cannot. Okay, so Militia, I guess once you grabbed the...
Okay, let me change the URL to host. Okay, yeah, so you have the host role now.
Okay, so let me just try and share again. Share slides, share.
There we go.
Okay, so folks can see the slides now?
Yes.
Yes.
Okay, so welcome to our lake replacement meeting for Vancouver. You see the chairs are Militia and myself. We're here. You know the charter, you have the mailing list, the Jabber room is there. We have 13 people in Jabber and about 30 odd on the WebEx, so please join if you can. We have an Etherpad. Michael Richardson is taking notes in Etherpad. Thanks, Michael. Sliding on, we have the Note Well applies. So I guess many of you will have seen this over the course of the last week if you took part in any of the virtual meetings. If not, please read it. And if you took part in the virtual meetings last week for the IETF, people were using this queuing mechanism in the WebEx chat. I don't know if we will need it or not. We'll start without using that people can just talk. If that becomes too confusing, we'll swap over to using that plus Q minus Q thing. Agenda. So here's our agenda for today, agenda bash, which is just now. I sent a mail earlier today to the list. There's kind of 3 issues I think might benefit from kind of a little bit slightly higher level discussion than just the details of the text. Then we got through the agenda as posted previously, which is the details of the working group last call and comments that are outstanding. And that should take the bulk of this meeting, and is the goal of the meeting is to progress that to the point where we can see the finishing line, hopefully. And if we get that done, then there's some presentation on kind of state of play of 2 of the possible AICs that people are working on, which is EdHoc and CTLS. And then any of the business as arising. I think we have 2 hours scheduled. Personally, I hate 2-hour meetings, but I hope we're a bit quicker than that, but we'll see how we go. So this is the moment for agenda bashing. Anybody have any agenda bashing?
Göran here. Can you hear me?
Yes.
Yes. So it would be great if we could reserve some time for next steps. So even if the working group last call comments drag out, I think we should have some time for next steps.
Fair enough. We will do that. So Militia, if you can remember in case I forget.
Yeah.
Okay, other than that, are we good with this agenda? I'm going to assume so.
I would just like to add that while we have a Jabber scribe, if any substantial comments should be brought to the mic and not on Jabber. So please refrain from having extensive discussions in Jabber.
Or bring those to the mic. Also, if you could add your name to the Etherpad if you're attending, that would be helpful, because there's currently 4 there and 36 people in WebEx. So please go to the Etherpad and add your name as having attended. That's our equivalent of a blue sheet. Okay, so that's our agenda. The three issues I sent a mail earlier to the list. I'm going to assume that people have read that. If you haven't, then you'd probably catch up as I go. So basically, the three issues I think that come up in multiple comments that were made on the requirements text. The first is how this relates to COSI core in particular. The second one is whether we might benefit if we recognize the reality that we have ad hoc and CTLS as candidate things, both of which are presumably likely to not go away. And the third point is kind of like how much precision is it useful to aim for with respect to lower layers in the communications environment. So I'd like to just take a couple of minutes to take each of those in order and see if we can come to some agreement on where we stand with respect to those, and then have that hopefully shorten the discussion of some of the detailed texts.
I can start with the COSI OSCORE part. There is a slide 4 in the requirements.
There is, but I would like to not go there just yet.
Right.
So essentially, I think there's a number of comments that were made. I made them on my own comments earlier as well, that the current text is very prescriptive about using COSI and OSCORE. As chair, I mean, it seems to me that will make it difficult for us to get rough consensus, because it kind of says you can't do CTLS. Yep. So I would like to see if we can figure, in general, what's the right approach to handling.
Yeah. So the current text is recommending COSI, it's not mandating COSI. Is that still so strong still?
Again, as chair, I would worry it is as chair, but I'd like to get comments from other people who make comments on this.
Okay, so just one more thing before letting the floor. So OSCORE needs COSI algorithms to be negotiated in ad hoc. So we can't go without mentioning COSI in the requirements. And then there are other aspects which we also go into, that we would like to avoid duplicated implementation of crypto wrappers. And there are other, I mean, the natural thing would be to use COSI, but that's beside the point. I think we can't go without the AIC delivering COSI algorithms to OSCORE. That's basically a no-go. So we need to mention COSI at some point.
Yeah, I think I raised this point. I think the point was, yes, you need to negotiate those algorithms for OSCORE as an output of this, but they don't need to be the same as the algorithms that are used for the negotiation.
And that's what the latest text is saying, exactly that.
Joran, you referred in your email to me to latest text. I've looked at GitHub and I don't see like a lot of changes. So am I missing something? Is there a branch I should be looking at?
There is.
Yeah, it's the working group last call update branch.
Okay, that will perhaps that explains why I didn't see, a bunch of things I was expecting.
It says the AIC shall support negotiation of COSI algorithms to be used in COSI in OSCORE. The AIC shall support negotiation of algorithms to be used in the AIC. So it doesn't say that you need to do COSI algorithms in the AIC.
So I just posted into the Jabber the diff between the WGLC updates branch and the last published one.
Sure. I mean, this text says it is strongly recommended that COSI is reused by the AIC. That's like prescriptive for no obvious reason.
So Eric, what would you suggest it say that could get move us to
that sentence be struck entirely?
I think it's quite natural to use COSI, but I kind of agree that it's maybe not what you should have as a requirement. Maybe state the requirement about code complexity and code size, and then write this can, for example, be achieved by using COSI. Then that aligns with a lot of other requirements we have in the requirements document about security properties.
Well, I can live with that.
Okay, great. Actually, Stephen, reading slide 4 would simplify for everyone in this situation, because we have the text there, so everyone can form their opinion.
Okay, but at a higher level, we will get to that. So the basic idea is that we don't want to be too prescriptive, but we do want to be able to mention COSI as relevant. Is that something that everybody is happy enough with?
I can live with that.
So hearing no objection, I think that's our. We'll get to the text later, but that's our kind of goal. So the second point I thought might be useful to touch on at a higher level than the text is it seems to me that the output here of from the IETF, if not necessarily from the Lake Working Group, is likely to be this set of requirements as a piece of text in an internet draft, and CTLS developed in the TLS working group, and likely, if this working group adopted ad hoc, then ad hoc produced by this working group. That seems like the likely outcome. However, we're in the text, we're talking about the AIC, as if there will only be ever one. And that seems to me, I think, to tee us up for a bit of, argument that we don't necessarily have to, if we just recognize the reality that it's kind of likely that ad hoc and CTLS will both get progressed to some levels at a different timeline in different working groups, and both trying to meet these same requirements. And I think if we can recognize that and be happy enough with it, no, we're not saying it's the perfect outcome, but we're happy enough with it, then that might help us not get stuck. So how do people feel about that kind of concept and recognizing that that's the case?
I think that's an excellent way forward. That's exactly what we've
What?
from Eric's side from the start.
No, I don't understand. Go ahead.
Yeah, so both to have a compact version of TLS and an ultra compact AIC that fits with OSCORE.
I mean, so not to put a final point on it, Stephen, but no, part of the reason why we're putting effort in here is we do not think it is healthy for the IETF to standardize a big pile of different AICs. And so if the outcome you propose basically predecides that question.
So I'm not posing it as an outcome. I'm suggesting I'm saying it looks like that's the reality. That's what's going to happen. So I'm not saying that that's what should happen. I'm saying that I don't see how anything. I think that's likely to happen. Put it that way.
Okay, but I mean, Richard, do you?
No, go ahead.
No, go. No, I was a little surprised to hear Stephen say that, so I'm trying to process it.
Well, I'm a little confused here because it seems like the chairs are the ones who would be in the position of calling consensus on exactly this question. So pre-calling this seems kind of out of order.
So I mean, Richard and Eric, I mean, we have a bunch of people who've been working on this ad hoc thing for a couple of years now. I don't seem to be going away. I mean, what is your hope that that CTLS will just cause them to say, "Oh, we were wrong"?
But let's look at what the standards here are, Stephen. Like the standard for publishing a document is not that people are tenacious and they keep hanging around. It's that there is IETF consensus.
Sure.
And so, like, we need to clear that bar.
Yes, but we're okay. But I mean, if the people who are, if that's going to be a block, then I think we should recognize that block, because that's going to basically mean this is a pointless working group. If we have a bunch of people who are saying, I'm arguing for ad hoc and I'm not going to argue for anything else, and we have a bunch of people who are saying, I'm arguing for CTLS and I'm not going to argue for anything else, that seems to me that that's just teeing this whole working group up for failure. If we can't resolve it, now if we can resolve it, great. But if we can't resolve it, that's basically just teeing us up for failure.
John Mattsson here from Ericsson. I think as one of the authors for ad hoc, we are definitely not only arguing for ad hoc. As Ericsson, we think a compressed TLS would be very, very useful. And I think Ericsson would use that in a lot of cases. I don't think the compressed TLS will be optimally small for the most constrained IoT development. And I don't think it maybe should. I think it should still be TLS. So I don't know. Ericsson would very much like to see both. We think both are needed.
So, John, I'm pleased to hear you say that. I think the operant question here is, if we acknowledge that there's use cases for CTLS regardless, I think the operative question here is, and the reason we're doing this requirement document is there a need for another protocol in addition to CTLS? Or can TLS be made compact enough to meet the requirements?
Yeah, what I've seen so far, I don't. So I think it seems like it's possible to do AKA in 3 messages for 551 byte LoRaWAN and 5 hop 6-ish. That has significant advantages from any protocol that would cause fragmentation. I think CTLS, I don't think CTLS will or should reach that kind of small messages. Then it would probably not be anymore.
Well, so, I mean, it may well be that that's the case, but I think the reason that Ecker and I have been asking for the precision in this requirements document is to come to a decision that you seem to have already come to. I don't have this, maybe it's because I haven't been in the space for a while, but I don't have the feel for the underlying technologies. But it's not clear to me that that's the case, given that even the early prototypes of CTLS have been getting in the same, within a small fraction of where ad hoc is. So this is why we need the precision and the requirements to do this evaluation. That on this question where you seem to have an opinion already, and that's fine. But I think we need to get consensus around the answer to that question, and build that consensus if we're going to make progress here.
So if I could jump in, this is Ben Kaduk. I think that, John, the question that Stephen is trying to ask you is roughly, would there be a case where CTLS is small enough that you no longer see a need for ad hoc? And what Richard is trying to say is sort of, you are acting like you assume the answer is that CTLS will not be able to get that small. And it's perfectly reasonable to expect that or believe that. But I think Stephen is trying to ask is it possible for you to change that opinion based on some data that we come up with the future work?
It was like, we want a document, we want a protocol quite soon. We also want, I think the current ad hoc messages are basically they are just as small as they need to be to get the optimized performance. And then I think there is message size. I have not seen any code sizes for CTLS, but it seems obvious that adding another encoding instead of CBOR and another crypto document implementation instead of COSI, which already is there in the OSCORE IoT device, would add code size and complexity.
So I'm going to, go ahead. I mean, sorry, were you done, John?
Yeah.
I mean, I certainly agree with John's basic principle that obviously, like something bespoke will obviously always be able to get, obviously be able to be optimized further than something that's not bespoke. I think that's clearly true. I think and going to what you were saying, I mean, the reason we are pressing on the requirements is precisely that we don't think we didn't think the objective was to be as small as humanly possible, but be small enough to not to be within the performance cliffs that these environments present. And so we're trying to understand where the performance cliffs in the environments are, so we understand the performance curve against which we're trying to design for it. And as one for myself, if it became clear to me that you couldn't hit those performance curves without doing things that I'm not prepared to do, or that the TLS working group thought were stupid, then I would be like, okay, screw it, go ahead, and I'm done. But that's not yet clear to me, which is hence my comments on the last call document.
So, yeah, I have a couple of comments here. The first comment is that although it may not have been clear in the document, but hopefully it is now, that there are strict limits specified. I mean, there are some limits where how much each message, how large the messages can be. And I hope we can come to that at the end of this meeting to understand that those limits are there, and they've been there for a long time, even if it hasn't been clear. We have been discussing this for almost a year now. And
you can summarize what are the size limits?
I think John did already. So we'd like to have, we are again stepping in ahead of the requirements slides, but we'd like to have an AKA which fits into 51 byte LoRaWAN at link layer and the 5-hop 6-dish 5-hop 6-dish.
Sure, but we know that is not possible for any public key-based protocol, any signature-based protocol, and therefore
it doesn't have to be signature-based.
Okay, that's correct, but like the requirements document itself says we have to have one that has signatures, and so if what you wish to design is a protocol which only is based on pre-shared keys, then like that is a different design problem. But the requirements document says it has to have has signatures, and so like I guess my point is like that yes, I understand like there's like a lower limit for the very smallest, most compact protocol with like the most compact type of crypto, and then the question is like where is the curve of cost for like every incremental byte and every incremental message, and like that's precisely the question I'm trying to get an answer to. And so I feel like I think I understand this 51 point, but I don't think it's responsive that question, because as I know we know we're gonna have to go over that 51 limit in a number of cases unless we're gonna say we're only designing a protocol that's pre-shared key based.
So this is when I was said static Diffie-Hellman, I was thinking of raw public keys.
Sure. Well, I again like, but the requirements document says we have to have a signature-based protocol. True.
So there's one thing that needs to be clear as well. So there are many scenarios to support, including certificate-based scenarios, which not necessarily would fit into these type of frame sizes. But for the cases that people are looking at, for instance, in LoRa Alliance, where they're trying to design a raw public key based replacement of the PSK based, that is the important case, to get the raw public keys within the frame size.
Okay, I guess I must say I find this quite surprising, given that the original designs of ad hoc were signature-based and therefore clearly could not fit into this limit. And the static Diffie-Hellman thing was only brought up quite recently. I'm finding this argument a little puzzling.
Okay, but that's since version 1, there's been mentioning of static Diffie-Hellman and signature and mixed cases. And for the benchmarks, well, what you need to address those with the raw public key. It doesn't say it has to be signature-based. So that's, basically what we see here is that the requirements are clear on this point. What is the optimal number of messages per packet stream? And we have an existence proof for a protocol which actually complies with that. And then if there are multiple candidates, well, we have had plenty of time to develop these protocols. We've been discussing this for many years now. For how long time more should we wait for another candidate to appear?
Well, in all fairness, you have been sort of changing your proposal over those years.
Actually, those requirements has not come from us. Those requirements has come from other people. When you say you have, then you are talking to the entire working group.
You mean as document author?
As document authors, yeah. Of course, we have written down the requirements from the working group. Yes.
Hannes is talking about ad hoc, the document, the protocol.
Yeah. The ad hoc is a solution. We are talking about requirements now, I suppose.
If ad hoc is the only solution that's going to be considered by this working group, then the requirements are kind of secondary.
I have a proposal that we move to the requirements slides where some of these things are actually so you don't have to ask the questions before. That be a way forward on this
Well, I'm not sure, Coran, because I see that we still haven't resolved the basic underlying disagreement here, which is I think that the people who are arguing for CTLS are essentially saying we don't want to do anything that's not CTLS if CTLS is good enough, and they're not. You're trying to make a case to say that there is a situation where CTLS can't meet the requirement, but I don't think we've kind of, if we could reach agreement on that is the case, and that therefore there may be a need for a non-CTLS based AIC, then I think that would give us a way forward. But if we don't have that agreement, then I think we're just going to talk about some requirements text and then get back to exactly this disagreement.
Well, I guess, but I think that's probably true, perhaps true, but I guess like the discussion we're having right now is precisely the one I'm asking for, which is that we have n application scenarios, and we have some n crypto scenarios, and then we have some set of packet sizes some curve of cost against message sizes, and that what we ought to be saying is, for each of these scenarios, this is the target we are attempting to hit for those scenarios. And so far we have, as far as I can tell, so my understanding is we have basically we have about 8 different crypto scenarios, ranging from PSK to signature based to full signature based on both sides with certificates. And that what I'm trying to understand precisely is what the message size and message number target is for each of those. And so like what I hear is John asserting that the message target for 2 of those, namely PSKs and static Diffie-Hellman, is 3 messages each 51 bytes, no more than 51 bytes each. What are the rest of them?
I think static Diffie-Hellman might not be a target. It's maybe PSK and RPK that is the thing. I think the users of a AKA doesn't really matter if they use a signature or a static Diffie-Hellman. They care about the performance and security properties.
So, sorry to jump in, but it sounds like Ecker is mentioning we've got this list of, call it 8 different potential crypto matching ups, and John, you're saying that maybe some of them may not be relevant to the application, and that's fine. But I think Ecker's point is that of these 8, and I'm again not 100% certain about the 8 number.
Yeah, whatever.
Of scenarios.
I pulled 8 out of my head.
There's like 2 or 3 of them that we feel like we have these concrete limitations in place of, that we think we can target the 3 frames and 51 bytes per frame. But then there's another 5 scenarios in terms of how the crypto algorithm primitives might match up that we don't have the same level of clarity about what we're actually targeting.
And I would note that even if we were just going to do an ad hoc working group, we would need those scenarios to know if ad hoc was done. There's, as Hannes pointed out, there's been a lot of change in ad hoc over the span of time it's been around, as people have talked about additional scenarios and additional mechanisms. So even just having a definition of done for whatever the protocol is, we'll need to know that set of scenarios that Ecker mentions.
Right, and I guess, and I think that also that goes to what the crypto is required. I mean, so this document I'm looking at right now says, like, in section 2.2, it says mutual public key authentication methods maybe need to be supported for RPK and certificate-based authentication. In the case of Diffie-Hellman key exchange, both the use of signature-based public keys and static DH public keys is expected. So, I mean, like, if that's not right, this needs to be fixed. And if the scenario, and be clear, if the scenarios are that we no longer care about certificates, and all we care about is like raw public keys, is exactly 2 scenarios, namely PSK and raw public key, PSK and then raw public keys that are static Diffie-Hellman public keys. Then like, world is a lot simpler, and like we should write that down. And then like, and then look at where we are then.
So I guess Ecker, sorry to jump in again once more, but Ecker, for this list of scenarios, do you think that what's currently in the requirements document is intending to be that list, or is close to that list?
I thought it was, but now I'm hearing maybe it's not.
I would I would not say that certificate is out of scope. There's interest in that, but I would say that if we prioritize something, it should be PSK plus elliptic curve Diffie-Hellman and RPK plus elliptic curve Diffie-Hellman, because these are the two things that are. This is what a very constrained IoT device deployment is likely to use, because it's what they can use, and it's also the space where it lacks, where the world lacks a really compact, efficient AKA. If you have certificate, then the size of the AKA overhead starts to make less and less meaning the larger your certificates are.
Sure. I guess I'm actually trying to like, I mean, so I don't know how we got, like, I mean, I think, you know, it seems like we got here by sort of a circuitous route, but I guess I'm wondering if perhaps the answer is to like radically descope this work, honestly. I mean, if so Yaron, you sort of said something earlier, which I didn't follow up on, but I thought was interesting, which is effectively that we have these situations where people are doing, you know, raw PSKs now, right? And they're doing raw public keys now?
Yes.
How are they? What are they using for the AIC?
For the AIC, yes. Or
no, sorry. The application scenarios this is intended to displace are ones in which people are using just like nothing or like just shared keys, right?
You mean currently, or what?
Yeah. What are the application environments in which this new technology is intended to be introduced?
So what I mean, what I know of, but this is the little I know of it, because Ericsson is not a member of LoRa Alliance, but it's a rumor that there is going on work on replacing the PSK, which is currently used for LoRa, with a raw public key based authenticated key exchange to provision the PSKs to be used. So that's one of the, and they're really looking for something constrained. This is exactly the type of setting that we are having lately. And there are other settings as well where people would like to move from a PSK-based provisioning scheme to a public key-based provisioning.
Right.
So do we need to like go through this list of 8 things and say like, what are people doing for this now, and what do people want to do with this in the future?
Ben, I'm not sure we do. I mean, it sounds to me like what's required here is an existence proof of a realistic scenario that CTLS cannot meet.
For the question that you have been attempting to get us to stay on topic for, yes, I agree that's the case. And if we're going to try to answer that question, then we probably only do need to care about these 1 or 2 most minimal of the 8 scenarios.
Yeah, and I think, and I believe now, I'm not sure about this entirely, but I believe that the feeling of the people proposing ad hoc is that they've already done this. That's what they've kind of been saying to me. And clearly if they have already done it, it hasn't kind of landed because it's not perceived that way.
Sure. So it's like,
well, and part of the reason done it, you know, there's not agreement that they've done it, is that there hasn't been agreement on what it is. I thought that was part of the point of this document, is to establish what the target was, so that one could evaluate whether or not, in fact, ad hoc was meeting all the things that that people apparently assume that they do meet.
So Richard, I think that's kind of right, but I mean, whether the idea of a requirements document was ever a good idea is a different thing. I think what we're getting down to now is that if there is an existence proof that there's a scenario that's realistic that cannot be met by CTLS, then that might give this working group a way forward. Do we all agree with that, if the existence proof is there?
Sure, but I'm not. I guess I'm trying to avoid creating a situation like an unbounded amount of work for people, which I think you alluded to in your email, Stephen. And I guess like I'm just finding. I guess I'm trying to. I find myself a little confused. I'm trying to figure out how to move forward because when this work was first introduced, you know, there was a lot of you know, there was a lot of sort of you know, measurement of scenarios which looked to me like they were isomorphic TLS scenarios, but were designed to be much more compact. So, you know, it would be like, well, it's still sigma and there's still signatures, but there's, you know, but like we're gonna like have the certificates out of band and we're gonna compactify the messages, or you know, et cetera, et cetera, et cetera, right? And if the notion instead is that and yes, there was like support for RPK, but there's like a pile of things, right? So there's a whole like list of like stuff, which is the very kind of thing that like TLS aspires to do, which is like a framework for like doing a whole bunch of things, right? And if the truth of the matter is that all that really matters is like raw public keys and in exactly two modes, which is shared PSKs and authenticating development, and raw public keys with static development, and like none of this other stuff is in scope, then like it does start to seem like it might be appropriate to design a new thing that was designed like not to have any extensibility and only do those two things and nothing else, given that like given that like those are not like things that I think are in the core area where TLS is trying to work. And so like I'm trying to sort out but on the other hand, this document has like a specification, effectively like a protocol which is has a requirement set, which is a protocol which is like essentially extensible to TLS and like covers many of the same application scenarios. And so I'm trying to understand whether those are real requirements or those are not. And in particular, like it like says certificates and it says like signatures. And so like, are those things real or are they not?
So there are requirements for the setting where you use mixed credentials as well.
Mixed credentials being raw public key on one side and PSK on the other, or certificates on one side, or what do you mean by mixed?
Mixed public keys. So you would have raw public keys on one side and certificates on the other.
Not transmitted.
But that doesn't meet then the size limits. And my problem is always like, and I've seen this numerous times, is at the beginning everything is portrayed as lightweight, and then you have all these even already at the fairly early stage, you have this laundry list of features, and then you only add more in a split second, and then it won't be that small anymore.
Adding more features doesn't make it less efficient for the case when you use static.
It sure does if you negotiate among those features.
Right.
While a TLS implementation typically implement basically everything, TLS 1.2, 1.3, a lot of cipher suits, hundreds of cipher suits, a lot of extensions. That's not the case for very, very, very constrained IoT devices. We expect them they will implement PSK authentication, and then they will use that. They will probably not support anything else than exactly what they have nailed.
That's true for web browser-based implementation. If you look at an embedded implementation, it's of course different because you can sort of compile out some of the code that you don't want. But with all the flexibility, there's some cost associated with it, and I don't see how you meet those requirements then in the sort of cases that you have outlined.
I think there's a difference between complexity and in the specification and complexity in what you can choose to actually implement. You can choose to implement just a small subset.
Right.
So can I interrupt this, Chair, if that's okay? I'd like to get back to, if there is an existence proof that we need something that is not CTLS, then I think we have a way forward. If there is no existence proof that's accepted, and if we don't have consensus that existence proof is there, then I really don't see much of a way forward, because we'll just keep repeating this discussion.
Well, I was trying to propose one, Stephen. Richard, were you talking?
I was going to ask, what existence proof do you mean, Stephen? Just so I understand.
So I think you and Eric were asking for, show me the scenario where CTLS cannot do what's needed. If a realistic scenario exists where that's true, then it seems there is a need for another protocol, and ad hoc is proposed. And then after that, we can discuss whether it should be extensible or how much cruft it should get. But unless we get to the point where we know if CTLS and something else, or CTLS is all that's going to be done, I think we're just going to keep repeating this discussion as has happened for a year or more.
Sure. So that's why I'm trying to propose a different way of thinking about this, because I think that which is that so I certainly hear what you're saying. But I guess like the reason, as I sort of said, the reason that I'm primarily interested in this initially was I think it's unhealthy for the IETF to standardize a large number of like big eight protocols is not being maintained.
Fine, large for us. 4, 10.
We already have too many, frankly.
So more than one.
Well, more than 2 or 3, which we already have more of, right? I mean, just look at
we have IKE, HIP, and TLS
and SSH.
Okay, SSH.
I mean, I'm just telling you. When we wanted to add, it was a multi-year effort merely to add new elliptic curves to protocols, right? We had a whole work group which I was add elliptic curves to protocols. It's bananas, and so like the so that's my philosophy. I mean, that'd be everybody else's philosophy, but that said, if we have and I think why that gets expensive is when we have a bunch of general purpose protocols. And so if there's an understanding that like actually this is designed for like a really special set of use cases that is not like a generic system that just happens to be slimmer, then I think it like makes sense to try to carve that off and be like, hey, we're just going to do that. But when I read this document is a requirements document for like a generic set of use cases. That's what gives me heartburn. And so I don't know if Ka or Kaba wanted to be on the wanted his thing related to microphone, but my suggestion was attempt to let them narrow the scope here, and if the scope was much narrower, then it'd be much easier to see how like it made sense to have like a custom protocol that like only did that with 1 or 2 things.
So again, speaking personally, I mean, I actually have some sympathy for that argument, but I don't think we could claim that it has IETF consensus that they're, that.
I didn't say it did.
No, I'm just pointing out. So I mean, while it does make a lot of sense to not duplicate, sometimes it does.
Sure.
Can I clarify? It's my understanding that the ad hoc proponents believe that they have provided that existence proof. Is that what you guys believe?
Pretty much, yeah.
Okay, and Eric and Richard particularly, and others who want to chime in, of course, obviously, you guys don't think that you've seen that.
I think it's very hard to say that we have proven that CTLS cannot do this. I don't know. As Carsten writes on the list, CTLS can be basically anything, I guess.
Okay, but that's the same criticism that people are making about ad hoc, so that it has changed. So I think my understanding is the ad hoc proponents believe that they have offered an existence proof that there's things that you can't compress TLS to do. And my understanding is that the CTLS proponents do not believe that they have seen that existence proof. Am I correct about both proponents' positions as of today? So Eric and Richard, you don't think you've seen this existence proof that there's a thing you can't compress TLS down to, or do you think that there is such a thing?
I mean, for such a thing to exist, we would need to have a clear statement of what the thing is, which is exactly what Eric and I were asking for in our last call comments.
Well, actually, you were asking for a little bit more. I think you were asking for a range of a panoply of options, or all the full kind of description of the environment. But if it's an existence proof, I think that's a bit more tractable.
Well, I mean, this goes back to Richard's point. I think about about choosing between 2 things versus knowing when you're done. I mean, so Yes, I mean, it certainly be the case. Like, certainly be the case that if like there was a demonstration that there's something that like one couldn't do by slimming down TLS without doing appalling things that we were going to do, then yeah, then like we said, then we have to say like that this is not a viable path. But I wouldn't tell you if you're done if like you have 8 different application scenarios or 5 or whatever the number is, and like you have no idea what meeting those application scenarios means.
Right. Can I jump in? So I think, Ecker, if I can sort of try and paraphrase what you were saying, if the only use case that we cared about was exactly the symmetric pre-shared key case, and we did not have an ad hoc that was also wanting to do raw public key and certificates and all this other stuff, and we were just focusing on symmetric shared PSK, then it kind of seems like we do have this existence proof that CTLS is not a good fit for that. Would you agree?
Let me try to nuance that a little bit. I think we'd have it. I think that what I would say is that. Well, okay. I think the actual phrasing you gave, I think, is probably right, which is to say, like, why would you pull in all this apparatus if all you wanted to do is that?
Right. And so I guess
that's it. But I just want to clarify that that's not a concession that CTLS does not have messages that are that compact, which is not true.
Okay, and so then I was going to try and follow on to say, but once you start on adding other use cases into scope, and it requires a lot more flexibility and options to be able to do or not do different types of things, then that gets you worried because it's no longer this very limited scope, and it starts to look more general purpose. And once you have this flexibility in the apparatus that you need for a general purpose mechanism, then it's no longer this very narrow scope, and it looks a lot more similar to TLS.
To the use cases that a general purpose AIC like TLS or IETF is designed for. Yes.
Okay, so what I think I was hearing from Ben's fine summary there was there kind of is an existence proof there for a very limited scenario. Kind of all, let me just say, we kind of all know that if somebody defines a protocol for that very limited scenario, it will extend to do other things. We kind of know that. That's kind of inevitable, I think, right? And that causes a worry. Now, so, that summary?
Not really, no. I think, I mean, the thing that made the part of Ben's thing that I found compelling was the specificity. It doesn't make, if you have a very limited scenario and you're willing to commit yourself to be only operating in a very limited scenario, then under certain circumstances, taking a generalized protocol and slimming it down to that may or may not make sense. And what I was saying was, if really all you wanted to do was PSK and and Diffie-Hellman, then hoisting even the CTLS apparatus in may very well not make sense. But that's not when you. But the reason I say that's not a proof in the sense you were talking about is that when you stack on the other application scenarios, listed in this requirements document, the limitation which motivated that conclusion no longer holds.
3 or 4 years ago, I think we made that exact determination. We looked at TLS and said, I don't think we can compress this at all the way that we would like. And so we created ad hoc. And then we got this multiple year long, we can make TLS work for you.
Well, many of the things were often at the beginning of a misunderstanding also where TLS is and how it can actually be used. Remember that there was a lot of effort spent in embedded TLS implementations, and those have been used for many of the IoT platforms. And obviously, people learned a lot on what works and what.
And actually, I have deployment experience with your code and problems getting it across networks. Okay, so I mean, yeah, we tried, and we failed.
So,
Okay,
Michael,
and so we
you
come back, we
claim
need something like CTLS. We need something like CTLS. We didn't have
I'm
that.
sure
4
I
years
can
ago.
help you with the problems with the code.
Michael, is this earlier attempts documented somewhere? Because that's the sort of analysis that we're talking about here, like looking at slimming
Like
down
the
TLS.
attempt to make it work. No, we didn't
Well,
attempt to make.
at
We
this point,
attempted to make DTLS work on constrained networks. We failed and said, "Gosh, looks like we need to do ad hoc, as I don't think we can push through something like CTLS through the working group."
Well, I guess I don't recall anybody coming to me with a proposal to do anything like CTLS, which presumably I would have been one of the first people to come to. What I saw was a proposal to do something entirely different.
Because we actually did the work beforehand, right? We actually did the work beforehand because you're not the only person that can figure out how to do, a bit of crypto, right? So
I don't remember citing that, Michael. What I'm saying is,
the point is, we're in a situation, okay, where it might be the right answer is that we should construct. What I don't know is do I need to create a compressed version of TLS, which is cryptographically and functionally equivalent to TLS, or am I allowed to transliterate that into something that looks like TLS but isn't actually compatible with TLS?
Mike, let's be like, this is sort of a history lesson a little bit, but at the beginning, it was actually, the story was portrayed as this is the application layer security solution and we are using it on top of TLS. That actually has prevented a lot of the TLS community to even look at this because they thought that this is something unrelated. Only much years later, we finally found out that this is actually supposed to replace TLS and become sort of like the TLS with a different encoding. That's why we are here.
That has never had a plan to replace TLS. This is meant to work in use cases where TLS obviously doesn't work very well. If you try to use current DTLS over a very constrained radio, it's not fun. You will have to wait a while.
I actually agree with that. That's clearly true.
Yeah. And this was not only one of the earlier, already from the beginning, a clear goal of this was to reuse COSI. We felt like we have COSI in these devices.
No, you don't.
Add code for TLS also. Let's see what we can do with COSI.
So that's the next misconception, because just because OSCORE uses COSI, it doesn't mean that all of it supports all of COSI. And you don't have COSI in the devices. I think you randomly mix stuff together. You don't even have co-op in all devices. It's like this is
this is
arbitrarily put things together.
Well, this is an OSCORE implementation we're assuming because we are building an AKE for OSCORE. It seems that many of the CTLS people are not at all interested in that part, but that's for your information. And what we have is exactly a COSI encrypt. We have COSI algorithms, and we have co-op, and we have CBOR.
For ad hoc, you need much more from COSI, which you don't have on the device.
No, the fact is that this is very tiny extension to if you have COSI, CBOR, and co-op, and that's one of the points. But I don't think we should discuss the COSI part because that was already item 1, and we are on item 2 in sub-bullet 2 in the agenda item 1. I think we should leave that and get back to this quantification of the existence proof, because that is what might lead us forward. I'd like also to add the time aspect here. We have a stressed timeline. People have implemented OSCORE in constrained environment, which takes a long time, and they want to have a key exchange protocol to secure their applications. So I think we actually should take care of the time we have in this meeting to progress work.
Okay, so the last I heard that I think I could summarize was there was a kind of an acceptance that there is a niche there that this existence proof could exist in or could fill. Yeah, an existence proof could, sorry, let me start again. There is an existence proof of a thing that you couldn't really compress TLS for. The last statement I think Ecker made was that if you try and define an ache to fill that niche, you inevitably will extend it to the point where it has to have enough mechanism that really you haven't filled the niche because you end up doing as much as CTLS does.
No, you said that.
I'm trying to summarize what you said. If I'm wrong,
no, I'm trying to say something quite different actually, which is that that my concern about this document, this requirements document, and this process has been predicated on the idea that there was going to be we're going to design like a generalized ache with like a whole bunch of knobs that basically did a whole bunch of application scenarios, and that is the source of my concern. And if what instead is being proposed, which I thought I heard John Mattson saying earlier, was a much more simpler set of protocols, which only does about two things, which is to say RPK and PSK, and is not intended to be generalizable to this full category of things, then it might possibly be the case that it was attractive to design something new rather than trying to like something else which was intentionally much more general. And so
I always thought we were doing what you're just the second part, Ecker. I always thought that's what we were doing.
Well, I mean, I'm reading this requirements document, and it has like 3 different ways to carry certificates. It has, it has signatures and let me start to be Hellman. I mean,
how can I have 3 ways of carrying certificates?
I think my last vote review identified at least 17 different scenarios that this requirements document envisioned.
The 3 ways of carrying certificates are by reference. Inline in a unordered list and inline in an ordered list.
So, I mean, there are certain important cases which are by reference, certificate by reference, and these cases where you identify the public key by hash or URL. Those cases are clearly IoT use cases. It's no point stripping down the protocol and removing those components from the protocol, because that will not be fit for purpose. But whether we need to have and then it also depends on what kind of deployments we're looking at. There is a wide variety of IoT settings, and as I mentioned or I think it's actually one part of the yes, it's actually the credential section speaking about we've heard companies mentioning this deployment path where you start off with a pre-shared key, and then because it's perceived as simple to starting point, and then you move, like LoRa Alliance is now doing, moving to a raw public key based provisioning, and then would like to take perhaps the next step and add certificates. That might not be viable in that application, but other applications may want to go that path. So saying that this protocol must not support signatures, or this must not support certificates, I think that's not the right starting point. But we could of course try to prioritize the scenarios which seems most relevant for IoT use case.
Okay, Stephen. Well, now we're in the scenario that you indicated I was concerned about.
Yeah, it's inevitable. I mean, that's going to happen, and I think it could make sense that, I mean, starting from the point where you actually have a simple application, simple setting with pre-shared keys, with an implementation of OSCORE, and the natural first step would be to add a PSK based AKE. That might not be the optimal from a security point of view or deployment point of view. So there are migration paths to consider as well.
Sure, I agree. I agree with that, but I guess, but I guess what I was trying to say, but the point where what you were proposing to eventually build is a protocol with an enormous amount of flexibility and sensibility for a pile of application scenarios, then yes, absolutely, you could accrete those things one by one, or you could start with a protocol which was somewhat more general and slim it down. And it's not clear to me why one would think that accreting them one by one, starting from nothing, is the right way to build.
But there's a very clear case that we need to support, and that's these scenarios where you are just using raw public keys and pre-shared keys. Those must be supported. So that's
sure.
you can go any way you like as long as you support those.
Sure. And I think the point Richard and I are trying to make is that we believe CTLS can support those use cases. And when the colloquy between Ben and I earlier was me saying that it seemed like that was a lot of complexity to absorb, potentially a lot of complexity to absorb, if the only thing you cared about was the use cases. But if what you actually care about is like a much broader set of use cases contemplated in this document, then suddenly that complexity argument starts to be much less attractive.
I think the prioritization is clearly RPK and PSK. These are the reason for ad hoc's existence. And I think the further you go in the other direction, if you have certificates with signatures, then I think then you will not have much difference between ad hoc and CTLS when it comes to latency and message size. Yeah.
So like there's maybe go ahead.
That was an end.
Okay. So I mean, it sort of seems like we have two different loci of functionality where there's a core area that it really is the primary goal, the primary thing it targets, and then it sort of creeps out or extends a little bit from there. With ad hoc being sort of maybe focused on its origins as the pure PSK or raw public key thing, and TLS, of course, starting out from the very full-featured web scenarios. And I mean, yes, it's sort of possible for these to evolve or get morphed or get crunched into some other scenarios, but there's like an overlap of the distribution between the two of them. And I think that's the space with this heavy overlap is what's being so problematic for us to think about. But I'm sort of coming to the conclusion, which could still be changed, of course, but if we do have a solid core of work that we want to focus on that, has the very constrained nature in terms of being the pure PSK raw public keys, it feels fairly natural to define a protocol that works for that. And if it happens to evolve into something a little bit more extensible, as Stephen is saying is inevitable, it's not entirely clear how concerned we need to be about that evolution, given that it has its origins and its focus in the more narrow case. And it just sort of, if somebody ends up using that in the broader signature certificate case because it's easier for their deployment because they're already using it for other reasons, I don't know how concerned I should be about that. Similarly to if someone is already using TLS and they start having smaller devices and they want to pack it down a little bit and get into a new use case scenario, that also does not seem very concerning to me. And I mean, yes, I agree with Ecker and Richard that we should not go into things and say our primary focus is to produce a general purpose AIC. There's just, but if we have a core focused point of work that we want to start with, and we could say, this is what we're going to focus on for now, and it might be extensible in the future to do some other things, but it might not too. And if it doesn't end up that extensible, we still think that there's value from doing what we're focusing on now. Like that sort of viewpoint is something that feels reasonable to me, but I don't know if that is the case for everybody.
So does anybody want to question Ben's description there, or is Ben's description of a way forward something we could live with?
Well, I don't quite understand what it means. So, I mean, does it mean stripping out basically the signature and certificate modes of this protocol, of those requirements?
I mean, so I guess I should apologize for coming up with something off the cuff that is vague and hard to follow. But I think it sort of touches back on a point that I had started to bring up earlier, which is to sort of consider what are the current and future expected use cases and or not use case, what are the current and future expected deployment scenarios or deployment scale for these 8 or 17 or however many different combinations of crypto primitives. And if it turns out that the only ones we know actually have current deployment or near future deployment are 2 of them, then maybe we don't need to spend a lot of time on the other 15 in the requirements document right now.
So okay, I mean, Ben, I would love that if that would provide a way forward. However, I don't know that it's possible to write a protocol that can't be extended into the areas that would cause concern to the people who like CTLS. I don't know if that's actually possible.
I agree. It doesn't seem clear that it's possible to write a protocol in that way, but you also don't have to write the protocol and spend a lot of time on the full generality of things. You can say, I want to write a protocol and make sure I get the narrow bits right. And sure, it's going to be possible to do the other stuff with it as well, but I can worry about how to do that properly later. And if it ends up being kind of janky because I painted myself into a corner, well, I have some other options for the more generic scenario.
So I'm certainly not like trying to argue we're designing a protocol which like no one has any idea how to extend ever. That would be unwise, right? I'm talking about what the requirements document and hence the implied charter for this work is.
Right, and I think your point is that the current requirements document is very generic and it doesn't give a sense of what is the focus versus what is, we're throwing it in there because we can.
But that's the nature of the IETF process, right? When you have a bunch of smart people who are saying, well, what about this? What about this? The people keep adding to the requirements document. That's just how it happens.
Okay. Well, I mean, but then I think the question is, the things to be cut out that are not out of scope of this work.
Or to try and characterize the way I think Ben was trying to describe it there is maybe there's a missing requirement to say the focus here has to be either on the really kind of tightly constrained, very, PSK plus RPK kind of modes, or on a generic thing, and those may not be the same solution.
Let's put the focus.
I guess this may be a way forward. I have to see some actual candidate text, but I mean, I guess this sounds like Benjamin moving forward.
Sorry, Eric, can you repeat that last? I didn't catch
I said this sounds like it might be a way forward. I'd have to see something concrete.
Okay, so let's be optimistic for a second.
Sure.
So people, please start typing in the Jabber room, in the WebEx chat, on the back of your hand, whatever, and see if you can come up with some text that tries to express that.
Should we do it in real time, or should we give someone an action to produce that text?
I was actually hoping we could do it. You're on your suggestion, because I also hate long conference calls.
So you want text for what are the prioritized use cases?
I guess I'm not trying to be difficult, but prioritize isn't the word I'm looking for. What I'm looking for is having this work scoped down to the point where it's not a fully generalized ache for like the end use cases that are currently in the specification, not in order of operation in which they will be designed. And if the idea is that we're going to first design, if this is like an open-ended charter, which is like, well, we're going to first design PSK, and then we're going to design RPK, and we're going to design certificates, and then we're going to design signatures and blah. No, that's I'm not cool with that. If it is, we're going to design this thing, and then maybe someday later we'll recharter to accent some stuff, then maybe, right? But my point is the scope of this specification is like a fully general wake, right? And so to go back to my colloquy with Ben quite a bit earlier, like that seems to be precisely the scenario for which TLS was designed, and so like I'm not really going to concede that it's not an appropriate use for that use case.
I still don't understand. We have problems, a setting where we think there is no good solution today, and we don't see any other solution. So why?
But
we list those prioritized use cases, and you need to comply with those. Why? That would at least be the sort of the scope where you can.
Sure, I guess. I guess what I'm looking for. Yeah, sorry. What I'm looking. Sorry, I thought we were having a different discussion. I thought if I understood what Ben and Stephen were attempting to accomplish, it was to create a target scope that would be a target scope not for this working group specifically, but for ad hoc to work on. That then the people who were interested in CTLS would think was a sufficiently small scope that they would not be interested in pushing CTLS for it. Is that what you're trying to accomplish, Stephen?
If we could accomplish that, I would be happy. Yes.
Right. And so, so just taking a list of things in this document and prioritizing them doesn't solve my problem. And so now, in my last call comments, what I was asking for was was for each of these use cases a set of like numbers that we were supposed to set of targets, which I still think is valuable. But like, if we're only going to do 2 of them, then like the number of targets we need is much smaller.
So what was exactly wrong with Ben's statement that we target certain use cases where this AK needs to perform well, and if it happens to apply to other cases, well, what's the problem with that?
In order to get there, you have to essentially, if you want to support all the use cases, you are designing a generic egg.
And exactly what is the problem with that?
I feel I'll just repeat myself. I think having the IETF have a big pile of generic eggs is bad. Okay,
so I think we have looped around to the top of the hour, the start of our call again.
Sure, I'm trying to respond.
No, I'm not blaming anybody. I'm just noting. However, I think just before that, we almost got to a possible point that might bring progress. So I think it's not kind of prioritizing. I think what we want to say is that there are some niches, there are some kind of deployment scenarios where we don't believe we can compress a generic protocol in a satisfactory manner.
No, I'm not. I'm sorry. I'm not going to concede that point, Stephen. It's the what I'm trying to say much more nuanced, which is that it's not worth. If all you care about is one very small set of use cases, it's not worth going to the effort of like hoisting in a generic compressed generic protocol. That's a different statement. Understand? If we're going to be designing for 8 different use cases, and even if any individual one only uses one, like then I think compressing a generic protocol makes a lot of sense. I can try to write that out in more detail, but like it's really important to be precise on what I'm trying to say here, because I'm not saying what you just said.
Okay, but I agreed with what you said, and I agreed with what I said, and I think we're different.
I guess.
Go ahead.
Well, I'm just trying to figure out whether or not we can plausibly make a way forward on this call right now.
So I did write some text at the bottom of the Etherpad.
Oh,
I'm not sure if it's the type of text people were asking for or not.
Oh, I'm glad we had that. I was like actually waiting for the Etherpad to show up, so I like lost it.
I'm gonna pull it up above into the flow.
Oh wow, we're like cleverly adding our names to the list of Etherpad. I mean, I would have to study this, but this is in the zone of what I was thinking.
Okay, so Mike, I guess, and again, it's perhaps this is text that we just need to take to the list and then consider. Does anybody have an immediate comment that this text seems absolutely crazy or absolutely wonderful? And somebody's child in the background obviously doesn't like it.
Yeah, sorry, I have my 5-year-old thing. My 5-year-old is concerned about X. He doesn't like X. I mean, like this. This is approximately what I was expecting based on what Ben said, and I didn't think that's a little more, but I think this is like in the zone of things I was thinking were sensible.
So Joran or John, have you had a chance to look at that, or?
To understand.
I think what Ben said before was very, very good. I some time to read, but.
I guess like I really hate. I'm sure other people do hate being asked to sort of agree to something on the fly. So I would suggest that we like this is text which I can think about for a little bit, and so the other guys can think about for a little bit too. And Richard already dropped off, so I think I would suggest we try to circle by email, and then perhaps you can schedule another call if needed to try to hammer something out. And if everybody's like, this is garbage, then we don't need to, right?
Yeah, I'm fine with that. So, okay, so the action, and if Michael, if you could get into the action is, we need to send this text to the list, ask people, does it seem to make sense as part of the whole thing, and possibly circle back and have another call if needed.
I will commit to reading this carefully and chatting it over internally and coming back in the next few days with my thoughts.
Okay, great. And I think we covered all three of the points I wanted to cover in all that discussion. I think, and yeah. So do we want to proceed with the agenda as previously planned then? And thanks for all the discussion. I think it's the key kind of disagreements that we're trying to get over here. Do you want to proceed as planned then with the requirements slides that Ran proposed?
Sure, yeah, that'd be helpful, because I think there were some points that were worth getting into.
Fair enough. I'll just try and find a way to present those. 1 second. Okay. Does that look like you expect it to?
Yes.
Great. Okay, so just say next slide as you need it.
Yeah. Next slide.
Oh, crap, where is it now?
That didn't work. You're on the same slide.
Right. Okay, so yes, so we are in submitted version 02. We got working group reviews from Christopher Wood, Richard Barnes, Eric Ruscorla, and Hannes Trofenik. There was responses posted March 24th, and there is the GitHub branch we're working on. And there were some updated comments from Maker last night. Slide, please. Right. I don't think we get into this, but yeah, go on.
Oh, and I'd like to suggest like when we get through, let's just be sensitive to, as we go through this, things that we're just recapping the discussion we just had and not do them.
Right. And I think also we should think for each comment whether this actually has to be solved in the requirements document or whether this actually more belongs to the design phase. Sure. So here is a new formulation, in case you haven't seen it. So it doesn't say shall. It says shall specify how to provide cozy algorithms to OSCORE. And then there is a recommendation because to avoid duplicated implementation. But we can sort of.
It sounds like we have some new text for that. Right. The rest of this looks fine. Well, sorry, the next, and this last bullet point, I guess, I think there were 2 points here, right? One is whether or not this should be reffing Cozy, and the second is what it actually should carry. But I propose we punt this because this seems to be the core of Ben's suggestion, and so maybe this will become irrelevant.
Okay, great. Next slide, please. Yeah, I think this is just.
That seems fine.
Yeah, next, please. Yeah, this is session identifier. this was put in by Kartik. And I think this is the purpose of this session identifier is for formal verification.
So
note that connection identifier is now removed from the draft.
right. So Karthik's on the line, but Karthik, did you just mean a Crutcher-Canetti style session identifier? Is that what you meant when you were saying this?
At the beginning or at the end, but particularly at the end, you do want to agree on a unique identifier for this agreed upon session. That's sort of the notion of freshness. That you cannot just use the same set of keys and generate a session key that would not be a session. So you need a fresh session identifier to point out this particular session. You need that both formal proofs, but also more practically, there should be something. And typically, this is a transcript. The transcript can be thought of as a session identifier in this particular sense.
Right.
Or it could be some other identifier that is. You need to have some notion of.
Yeah, that makes sense. You want to rephrase this somehow, Ecker, or are you happy with that?
Let me just see what we did. We tried to solve this problem in TLS. Let me just see what we did there, because I think
I mean, as Kartik says, this is when you think about, maybe that's not what you think about. It's like a transcript rather than.
Yeah, I mean, so we had this. No, but we actually had this because like we talked about what the informal design goals were. If I can just find the damn thing. Hang on a second. Let me just. I'll take a look and try to find some text. Like I found this very confusing to people, very confusing because I wasn't sure what it meant. But like I'll flow some text for that. It's not a problem. I agree with the objective.
Right, so then we have the discussion about misbindings. And so the note here is just saying that we do want to support the case of, for example, hash of public key or the public key itself. Both of those settings are relevant.
Right. So the issue is, and Karthik, I'm sure can talk about this more than I can, but that if you treat people's public keys as their identities, then you get identity misbinding problems. Because it's unless it's impossible to register a public key for which you don't have proof of possession. I mean, this is the heart of like what Sigma covers, right? And so the classic way to do this is to include the identities of the endpoints inside the transcript itself. But if the identities of the endpoints are merely the public keys, then you don't get that property. And so that's the reason I'm pushing on this. Now maybe we can just like hand wave this some, but that's the reason. That's what I'm pushing on. Karthik, am I representing that correctly?
Yeah, more generally, whenever we talk about authentication, we have to talk about identity and what the identities of the two parties are. And that is a little bit open here because we have so many different ways of accessing identities, including the raw public key. I don't think this is going to change, but if there was some notion of kind of a global identity that you could use that the devices knew about each other, then that would make this much more explicit. But I agree that there is a concern that if what we are agreeing upon is the keys, but what you really wanted to agree upon was the identities, then there is a gap between what we are authenticating and what we wanted to authenticate. But I mean, if you had only one mode, it's very easy to make this very precise. If you have 3 or 4 modes, then we have to be careful about what is this notion that generalizes across PSKs and RPKs and certificates. It's not clear.
So do we need to change the requirement? I understand this is an issue in verification, but do we need to change anything in the requirement here or in the text?
I guess I'm going to let this go, but I think when we actually define as protocol design, we're getting important to understand. And actually, I mean, like, so to be clear, what 7250 in TLS has this problem, right? Which is to say you could just name, well, so if you name RPKs, it has the exact same problem where basically there's no guarantee of misbinding. So when we actually do the protocol design, if we with any kind of RPK, it would be important to stipulate what the guarantees you're attempting to provide are. But I think we can put a pin in that, I think, though.
I agree with everything said here. I think the actual solution need to match what the actual deployments are and what kind of identities can they provide, what is reasonable input to the AKA.
Yep.
Just I want to check, John and Joran, are you okay with kind of taking your own notes or going back to the recording for this? We're just Michael has to go off to another meeting, so I think we may be losing our note taker.
Okay. We'll take notes from here then.
Okay, great, thanks.
Thank you. Next, please. This is the new replay protection formulated by Christopher Wood, I think, or yeah, something similar like that.
That looks good to me. I wasn't able to find that because I didn't understand the branch, but that looks fine.
Okay. Next. Right. So yes, this is sort of the property that you don't really verify. I mean, you basically just verify the public key. I mean, this is related to the identity, probably, but you only verify that the public key, the signature matches the public key, but you don't verify that the public key actually is the identity you intend to authenticate to.
Karthik, I think you wrote this. What did you mean?
No, this is not Karthik.
Oh, okay, sorry.
You can't blame him.
Oh, okay. I was going to blame him anyway.
Yeah. So I guess there's two questions here. One is about authorization. Is it that you want to make sure that this is the identity you actually you wanted to authenticate?
Yeah.
But the other one seems to be, I'm just trying to read this text carefully. Both parties should agree on the identities of both parties. Since if somebody authenticates to me, if Alice authenticates to me as part of the protocol, I also need to know that Alice intended to authenticate it to me and not to somebody else. And that's sort of related to identity misbinding, but it's kind of called recipient authentication, not just sender authentication. So I need to know that both parties agree on the identities of both parties. I'm not sure that's exactly what is being said here, though, but no, that would be a natural thing to say.
Could you propose a rephrasing here?
I think we actually
I could give it a shot.
Didn't we have some crappy text for this in 8446? I think it feel like we did. But Karthik, it sounds like you know what to do. And I agree that's a good objective.
Thanks, Karthik. Next, please. What's this now? All right. So yeah, this is actually your comment is about the third paragraph. EFS may be achieved in different ways.
Right. So I should yeah. So I think the proposal looks fine, and the stuff in red looks fine. I guess the reason that I'm like I didn't write my comments very clearly, but I think what I was trying to get at here is that there are non-protocol designs that the way you actually build your implementation that lead to like compromising PFS. As an example being any kind of ticket-based resumption scheme. And so, as I understand it, we are specifying resumption here, which means that there might be possible to build a ticket-based resumption scheme, in which case you'd be violating this rule. And so I'm trying to understand how do you actually write this rule in a way that seems sensible? Even if you do I guess if you're always doing Diffie-Hellman, then you're going to say you don't have this problem. Because you don't have 0RTT, so maybe I'm projecting TLS behavior onto this. So if I guess going back to the previous thing, you said no 0RTT, and it's always doing Diffie-Hellman. So we're not doing it. I guess, are we thinking we would design a resumption mode that didn't have Diffie-Hellman? Or that would just be hoisted onto OS core, and so we wouldn't need one.
So
the first.
I haven't seen any resumption mode. Have you?
No, we haven't talked about that. Do we need to determine that now, or can that be left to the design phase?
I think this isn't like a law. This isn't like an actual loss. So like if we conclude this text is wrong, we'll just deal with it. So fine, yes.
Okay. So we leave it as is then.
Yeah, sounds good.
Thanks. Next. This was one comment by Christopher Wood. He has asked the question about hybrid, sort of simultaneously more than one key exchange. And I assume that is out of scope. I wrote that here.
I think it should be. I think we agreed on that previously, so I'm not sure how it's knuckled its way back in.
Good. And then there was a clarification about elliptic curves, that they are also in part of the negotiation. Previously, it was missing the statement that protocol shall allow negotiation. It just stated that protocol shall allow multiple elliptic curves. Okay. Next. Yeah. Okay. So this was the the statement about what is the result of a successful negotiation. And yeah, we proposed, or someone, I actually can't remember who, proposed that we should have the least, the most preferred algorithms, because, I mean, you could be less specific. You could speak about strong integrity and negotiation integrity and so on. And yeah, we're happy with that. Just wanted to point out that might lead to the least.
I mean, yeah. So I think it'd be fine if you told. I think it'd be fine if you told the endpoints that they had to that if the final protocol required you to negotiate a certain way. So like, I mean, like let's take a protocol like you know, any protocol that has like an offer answer structure, right? Where the offerer gives like, you know, his ordered list and the answer has to do something, right? Like it'd be fine if you told the answerer he had to do like, I don't know, one of the two things. Like the two things people typically do are pick the one on their list as my favorite, or pick the one on my list as their favorite. And it'd be fine if you told them they had to do one of those two things. I just don't. But the protocols, but no protocol I'm aware of guarantees that without like a bunch of extra bullshit.
Okay, so what I found is that this section actually contains the text below, which states properties about strong integrity and downgrade attacks. So we could simply just remove this, the first bullet there. I hope you're happy with.
Sounds good.
Great. Next. Right. So coming back to that paragraph. So the question is, should we quantify strong? And I think after the buff, there was a mail exchange where someone proposed exactly this, and then the list decided that was not necessary. And then we also have the, I mean, we don't need to go into curve with 229, whether it's approximately 228 bits, but we definitely want to support max shorter than 128 bits. So we might want to add something stating that, as you proposed, that we should have equivalent of 128 bits integrity, but that we allow shorter max, something like that. Would that be acceptable?
I think Karthik and I had a long conversation with this, so I'm not sure. Do you have some text in mind, Karthik?
The bits of security thing is pretty controversial anyway. But in general, people do understand it well. So if we had some informal target saying 128 bits of security, that people will understand what you can instantiate with. So you might be able to get away with shorter max for sure.
I'll tell you.
But we're still achieving the same level of security.
I'll tell you what. How about I float? It sounds like you're open to something that's in principle. So why don't I float some text, and then we can decide after we see some text if like this is a good idea or if it's a bad idea.
Yeah, sounds good. I think your suggestion here is fine.
I'll send a PR then, and then if people like, I mean, like, and with the understanding that people might not like the PR when they see it.
Thank you. Next. Yes, this was proposed partly by Chris, I think. It's basically spelling out what is the sigma I and sigma R in this respect. First paragraph, hope that's clear now. The second paragraph is on, just noting that some information may need to be transported in plain text. Identifiers to log correlation between messages and ciphertext.
That makes sense.
Notably, the PSK identifier.
Yes.
Yes. Why is that? That's presumably mentioned in some other paragraph. So yes, that's this is just other than that. Yeah. And connection identifier is removed from the graph. Okay. Next, please. Yeah, we have the auxiliary data. There was some comments around that.
One question, John, on this identity protection. There was also the issue of this unlinkability. Was that related in the part with identity protection, or was that in a separate section?
So you had one comment about privacy,
yeah,
and that we added the privacy consideration.
Oh, okay.
At the end. So that's basically the privacy consideration currently in the document. And this was about auxiliary data. Hannes had problems about the access token being mentioned here, so we removed this text.
Okay.
And it's also had a concern about CSR and the use of CSR. That he would like to see that more like early application data. And in fact, if you use, like is proposed here in this example, CSR in the third message, that's very close to early application data. I think that this is sort of an alternative way of passing the certificate signing request. And then finally, Richard proposed a formulation for protection of auxiliary data, which we thought was really good. So we copied that. Any more comments here?
Nope.
Next, please. Yes, now Michael left, did he? That's a shame. So this was comments, some text that Michael put in, and Becker commented on, and Michael responded to. What we, as working group, could discuss is whether we think this is actionable or not, whether this is a requirement.
I mean, I guess I think this is. I think Michael's text here, I basically think is like not unreasonable. You know, this is goes back to like Adam Langley, have one join and keep it well oiled. You know, I guess I probably wouldn't put this text in here because I don't think it's actionable, but I'm not going to fight about it if people think it's important. Because I agree with the philosophy being espoused here by and large.
But nobody would disagree with that, right? Nobody wants to create protocol and put stuff in there that nobody understands.
Right, but is there a harm having this text in this requirements?
I'm not going to fight about it.
Okay, so let's keep it. Next.
I misunderstood this. I misunderstood this text. I agree.
Okay, so this is
yeah.
If that's clear.
Yeah. I just misread it. And thanks for pointing out to me in your response.
Okay. Good. So unless there are, then there are good 2.9. Then now service. Richard commented that the first paragraph was overlapping very much on the now service stated on underlying transport. We removed that and then realized that this section should probably change to availability. Now, to understand if that's right, I should have copied in the actual text, but it's basically. Let's say now that text is saying
something that you should not be able to like send a single message and get some node to lock down for a long period of time, something along these lines, but not exactly that.
So we could look at that, or you could send comments if you have problems with the new title of the section. Otherwise, we move to the last subsection, which is the lightweight part. And so here's the new, we were clarifying some of the benchmarks. Here is the new information, which in this.
Yeah, so I'd like to take a step back on this. I think this is the part that was like super contentious at the beginning, and I think like I'm happy to read your diffs, but I think I don't want to argue about these right now.
Okay, perfect. So what I did is basically noted that what you requested in your email, I put that here, that text intended here is to show what's expected to be achievable. and RPK with static Diffie-Hellman keys are feasible for that. That was one remark from my side. And then next slide, please. So we actually did some of this in preparation for the SEC dispatch interim March 2019. And the benchmarks are exactly, or at least that I can tell, the type of properties that's requested. There is LoRaWAN time of error, there's the backoff time. And those spreadsheets are actually intended to use. So it's not yet calculations it is currently calculations for specific protocols, but the spreadsheets also, there is a how-to basically, how you fill in your message sizes, how you get out the time of error. So it essentially provides the type of data. It's not plotted as a graph or something like that, but it provides the type of data I think you requested.
Okay, well, I can certainly take another look at that.
Thanks. And the final slide on this topic is this is what produced those type of diagrams that we looked at.
Well, I can certainly take another look at that.
Okay. Yeah, so we have some issues to resolve. If I remember right, there were actions to Anchor and to Kartik. Did someone else get action?
Yes, I noted them in the minutes. So there was an action point for Ekar and Kartik to propose, so what is this, on identity protection? No, I'm sorry.
128 bits.
Let me see. Yes, exactly. On the security strength, and that's about it.
And then authentication.
Yes, exactly. So it's captured in the minutes.
And the question on scheduling, is it feasible to try and resolve these actions in, let's say, the next 2 weeks?
That's good.
Sounds good.
I'll try my best.
Okay, let's do that as a go. I mean, I realize there's a whole bunch of other working group sessions going on in the next week or two, so people are busy, but let's try for that.
Okay.
And what about the text that Ben provided here? What do we do with that?
I was hoping to spend a few days looking at it and talking to people, and then I was going to send comments, some of my thoughts on it. I was hoping you guys would do the same.
So I guess somebody.
Yeah, please. I'll
Go ahead.
And that will end up in the requirements document?
We'll make sure it gets highlighted to the list out of the minutes, and we ask people to read about it, think about it, see what to do about it, including possibly put it in the requirements document. Okay, so that was your last slide, sir?
Yes.
Right, so that's good. So we had a couple of quick kind of status updates on ad hoc and on CTLS. Currently, this is ad hoc first. Do you want to stick with that and maybe just take like 7 minutes each?
Yep.
I mean, I will need a minute and a half, so whatever.
Okay. Well,
Yep. I will keep it.
Okay.
Should
Yeah.
do you share the slides or? Yep. Great. So this is version 01 slide. So this lists the changes since the 01 version. Basically, we have tried to implement all the suggestions from the working group, try to fulfill the requirements, try to optimize the protocol even more, which is also aiming at the requirements. And then we have made some clarifications based on people trying to implement and do formal verification of ad hoc. So the algorithms of ad hoc and OSCORE are now independent of each other. We have, as was a requirement, we have added a mixed mode, and we'll go into that later. The key derivation for the static Diffie-Hellman mode is now serial instead of parallel, as based on a suggestion from Kartik on the list about static Diffie-Hellman. The design has changed to Mac then sign instead of sign then Mac. It's now similar to IKE. Reason is that it made more sense with its mixed mode and that it saves bytes. The
identifier encoding has been optimized so that there is a lot more values that take a single byte. We have made encryption of message 2 in CPA, so no integrity protection. As discussed in the Sigma paper, this can be done. We have added an optional integrity protected subject name for RPKs to protect against misbinding attacks in cases where you can assign a subject name to the key. Then several clarifications and a lot more test vectors. We have implemented almost everything in the specification now. Next slide. So this slide's illustrating new method types. So 0, 3, and 4 was what was there before. 1 and 2 are the new mixed, where you have one party authenticates with a signature key and the other with a static Diffie-Hellman key. And this is to optimize the requirement that one party should authenticate with a certificate and the other with a RPK. Then you get the least overhead if you do signature and static Diffie-Hellman. Can take next slide. Here's as requested by Michael, slide illustrating the new mixed asymmetric mode. So the method parameter, which is the first integer sent, can be 0, 1, 2, 3 for this asymmetric mode, and that integer determines if the responder authenticates with a signature or a static Diffie-Hellman key, and similar if the initiator authenticates with a signature or a static Diffie-Hellman key. And then you get 4 different possibilities. And this has been implemented with a single field called signature and MAC after a suggestion by Ecker last meeting. There's still some trade-offs, as we can see, between security properties and performance. Basically, with the static Diffie-Hellman mode, you get, if you mix in these ephemeral static keys, we think you get a little bit weaker authentication properties. But on the other hand, you get stronger security properties in case of a key compromise. I think that's something for the working group to discuss in the future. And then the blue dot here, we have changed this to in CPA encryption without integrity. And the reason you can do this is that the encryption here, the second message is always only protect against passive attacker. An active attacker in the Sigma protocol can ask the responder. The initiator is not authenticated before message 3.
So John, what happens if the initiator takes some action based on the auxiliary data?
The auxiliary data is signed.
Okay.
Or MAC'd. It's included in the inner MAC and the signature if there is a signature.
Okay, I misunderstood the section you were covering. Okay.
Yeah. So, next slide. And this is the last slide. Here is a summary of the message sizes. So all sizes has been message sizes for the PSK plus ephemeral Diffie-Hellman has been slimmed a bit because of the new optimized coding of identifiers. The RPK case is now a lot smaller as static Diffie-Hellman keys is used instead of signature keys. And with these numbers, we can see that we will be able to fit ad hoc into 3 unfragmented frames in 5-hop 6-ish. The limitation there is 45 bytes per payload, and we can do the same in 51 byte LoRaWAN, and the limitation there is 51 byte frames minus the SHIC.
Oh man, it's really a bummer you're 1 byte short on the RPK plus ECDHE for the 6-tish, huh?
What?
So you said the limit, yeah. So you said the limit is 45. So in 6-tish, we're 1 byte over, huh?
As the first bullet here says that we have identified that we can save a few more bytes.
Okay, good. Okay, yeah. I was gonna say that's like that'd be super irritating.
So there are several length fields that are known, either crypto algorithms which the fields are known, or some fields that are actually encoded several times.
Right.
We can save, I think, at least 2 bytes here for this 46, which we can implement later, because this is an important goal to meet. And that's it.
Okay, any just change slides to the CTLS ones. Any questions on how we're doing that, or I think it's mostly to be taken to the list, really. Where is this?
And don't bother my slides, because like my slides were much more like overview of CTLS. I mean, I think I don't have like a nice diff the way that John does here. I guess the most relevant things are, we're continuing to update it. We have several implementations in progress, one in Rust and one in Go. It's been adopted by TLS sort of, in that there was a hum to adopt it, and the charter it's now being rechartered. So I don't know what the status of the charter has been, but I assume we're getting pretty close. And then as soon as the charter is fixed, then we'll be actually submitting the working group version. And we're working with Karthik and others to adapt the TLS 1.3 proofs of security to CTLS.
The charter's on next week's telechat. I didn't see a need to rush it before.
No, not at all.
So,
not at all. No.
Next one.
I've been working on a C-based implementation based on our embed DLS.
Sorry, Hannes, I didn't get you online beforehand. I didn't want to like. When I had slides, I didn't want to promise something for you.
Okay, great. So we have like 6 minutes left. I think we have a we have a set of minutes about the requirements. People have a bunch of actions that they will try and fulfill in the next week or two. We'll hope that Ben is being a great idea and saving the day with his suggestion for how to characterize things, and work, I guess, on ad hoc and CTLS continues. And with that, I think that's our agenda. Is there any other business or something that I forgot or we skipped over?
Thank you.
Hearing nothing, thank you all. And we'll discuss on the list and as necessary organize other meetings. So thanks very much for all the discussion, guys.
Thank you. Bye-bye.
Thank you.
Thank you.
Thanks, everyone.